Right, this is the pre-lab for week 2 of the lab, how is liquid ethanol produced and purified, and recall the technique that we're using is distillation. You've now seen that distillation can be used to separate and purify liquids by taking advantage of the differential in boiling points. And simple distillation only works really well if you've got more than a 25-degree difference in boiling points. And fractional, we'll see, can work much better if you've got two liquids that have less of a difference in boiling points. So last week we used a simple distillation. And recall that you have steps in a distillation. The first step is called vaporization. And at that point the vapor is enriched with the lower boiling component, which in this case is ethanol. Then you have a condensation step, and that allows you to collect that vapor as a liquid that has a higher concentration of the lower boiling component. Now in simple distillation we have only one vaporization condensation step. And that vaporization condensation step, each one of those is called something called a theoretical plate. And simple distillation has only one theoretical plate, and fractional has many, many theoretical plates. Now here is a phase diagram that helps illustrate how fractional is better at separating liquids than simple distillation is. And what this is a phase diagram, and you can see along this axis down here we have percent ethanol, and along this axis we have the temperature. Now note the temperature is in Fahrenheit, but this is the only one I could find, so that's why we're working with it. But remember, we're doing everything in Celsius. Now as you look at this, you can see that there is a solid line right here that I'm outlining in green, and that is the liquid phase, and then there is a dotted line that I am outlining in red, and that refers to the vapor phase. So everything above this is in the vapor phase, and everything below this line is in the liquid phase. And also note that along the x-axis we start out with percent ethanol. We start out with 8% and move to the highest we can possibly get, which is 95%, because that's the point at which the mixture forms an azeotrope. We started out with about probably an 8 to 10% solution of ethanol. When yeast is fermenting sugars into ethanol, when the concentration gets above a certain point, and it depends on the type of yeast that you're using, what happens is that the ethanol concentration kills the yeast. So that's why you can't get much higher than 8%, well, like I said, 8 to 10% with the kind of yeast that we were using. Okay, so let's say that we started with roughly an 8% solution. That is, then when you did your simple distillation, you heated that to boiling, and then as it moved up into the distillation head, we went from, that's what I'm showing, we're coming up here, and we're making that transition from liquid to vapor, and then the material is condensed. And that is one theoretical plate, and you can see that would give us for this phase diagram, that's going to give us about 43% ethanol. And I think most of you, when you were telling us what you got as the percentage ethanol in your distillate from the simple distillation, you were getting about 30 to 40% ethanol. So that makes a lot of sense. Now, we're going to take this material and we're going to take it through a fractional distillation. And as we take that through a fractional distillation, here's one theoretical plate right here, and that would give us 68%, but we're not going to capture it. We're not doing another simple distillation. Remember, in the because we're going to add in a extra piece, which is called a Vigoro column, we've got additional theoretical plates. And so we can have another vaporization condensation step and another vaporization condensation step, and these get smaller and smaller and smaller until ideally we'd get to our maximum, which is about a 95% ethanol solution. And so that's what we're shooting for in this lab. So as I said, simple distillation has only one theoretical plate or only one vaporization condensation steps. Fractional distillation has multiple theoretical plates or vaporization condensation steps, and how many is going to depend, how many theoretical plates there are depends on the fractionating column. And there are different kinds of column packing that you can have, glass rings, steel wool, glass beads. What we are going to use is something called a Vigoro column. Now yours is not going to look exactly like this. This was the piece of equipment I had in the drawing program, but it is close enough. And the MIT video, they used a Vigoro column in their setup. Other than that, it's going to be pretty much exactly what we did last week. You're going to take your 50 milliliters that you collected. Now we're going to have a much smaller flask here and a smaller heating mantle. And in this case, we're going to find you may need to use the sand to fill the heating mantle because we don't have that many heating mantles that fit a 100 milliliter flask perfectly. But other than that, the setup is exactly the same. The only difference is now, instead of just collecting one fraction, you're going to be collecting multiple fractions. So to focus in on week 2, as I said, you're going to use what you isolated from your simple distillation for the fractional distillation, and then we're going to check the density of fraction 1 and get the percent ethanol from that. So some notes about those fractions. Fraction 1 we're going to collect from 77 to 80 degrees Celsius. And don't panic, the temperature is going to stay the same for a really long time, and then it's going to jump up really quickly. So do not panic when you see the temperature increasing. It's going to stay between 77 to 80 degrees. It may get close to 80, but it'll stay there for a while, and that's hopefully when you will have distilled all of your ethanol, your 95% ethanol. Then you're going to have a pretty quick increase, maybe a slight drop, and then a big increase in temperature, and that's fraction 2. And then finally fraction 3, hopefully at that point you are just collecting water. Now the MIT video stated that you should discard the first few drops of the distillate, and that would be the first few drops of fraction 1. Do not do that. Just keep everything in fraction 1. And that's it. You'll see my assistant this week is very bored with distillation and would like us to move on to something else.